Welcome back to Industrial Biotechnology course. Now, I was discussing about the ethanol fermentation process. In the last class, I discussed that how the ethanol production takes place, what is the different type of raw materials is used for ethanol fermentation process, and that we have two type of alcohol, we have tax alcohol, non-tax alcohol. Then we discuss distillery, distilled liquor and non-distilled liquor. Now, in this presentation, I am going to go little bit in details, and at the end we also discuss some advanced ethanol fermentation process. At the end, I shall discuss one problem related to the ethanol fermentation process. Now, the question comes, what are the steps involved in the ethanol fermentation process from molasses? I told you that molasses is considered as a very effective raw materials for the ethanol fermentation process. Now, why the molasses contains is considered as a very good raw materials for the ethanol fermentation process? The reason is that it contains the vitamin like biotin, inositol and pantothiol. And if you look at the vitamin distribution in case of beet and cane molasses, in my one of my previous lecture I mentioned that cane molasses is largely available in India and beet molasses is mostly available in the western country. Though in India also, in South India, southern part of India, some places we produce beets, and from that also we can produce beet molasses, but number is very few. And if you look at the vitamin distribution in beet molasses and cane molasses, the biotin, inositol and pantothiol, that plays very important role in the alcohol fermentation process. Now, if you look at biotin, as for example, if your media does not contain any biotin, then lag phase of the fermentation will increase. Lag phase of the fermentation increases. So that is undesirable. You can remember when I discussed the growth cycle of the cell, I told that this is considered the lag phase. So these lag phase should be as small as possible. If we have very less lag phase, then our fermentation time of fermentation can be reduced drastically. So biotin is a very in presence of biotin, the lag phase can be reduced. So this is the essential component required in the fermentation broth. Then inositol, if the inositol present, then your absent, then the organism relax to ferment sugar. That is undesirable. So this is another. And pantothiol, if pantothiol doesn't present, then your organism easily undergo the autolysis. That is undesirable. So if you look at this vitamin, in case of beet molasses, in case of cane molasses, their percentages varies. That in case of cane molasses, the biotin content high. In case of beet molasses, biotin content comparatively less. But other two vitamins are quite significant. So it is recommended that if we mix beet molasses and cane molasses in the ratio of 1:1, then it is ideal for the alcohol fermentation process. So first, in case of alcohol fermentation process, first we shall have to prepare the starter. Starter is nothing but that is the culture. You have to produce the culture, and I told you that if you look at the volume of the culture, usually 5 to 10% of the fermentation media. Then raw material addition, you have to add some raw materials. The nutrient addition, if it is required, then you have to carry out the fermentation process. Then distillation. So these are the couple of steps involved in case of ethanol fermentation process. Now, if you look at the process flow diagram of this ethanol fermentation process, this I have taken from this source, and it is like this, that the cane molasses, I told you, you can remember that cane molasses is a seasonal raw materials, because cane produced in a particular season, not throughout the year. So every industry, they have molasses storage tank that just in front of their main gate, and the huge, very big tank, and where they stored the cane molasses for whole years. And then from that, they, with the help of pump, and I told you that this, since it is a very viscous liquid, we use the gear pump, the special type of pump used for dragging the viscous liquid from one place to others, and we take it to the molasses measuring tank, where before the fermentation we take the desired amount of molasses and then we dilute it, then and add some nutrient, then we pass it, put it to the fermentation vessel. So it is like this. This is molasses storage tank, and then we take it here continuously. We dilute this, then we can do the sterilization, because for the yeast inoculum preparation we shall have to sterilize. When you go for this ethanol fermentation, we don't require the sterilization directly. This media can be used in the fermentation tank, but when we prepare the culture is prepared under aerobic conditions. So here we require the sterile media, and then here the yeast storage tank, then from that we put it in the fermenter as a inoculum. After the fermentation is over, it passes through the beer still, where heat this material, passes through the distillation column, and from the distillation column we can separate the ethanol. Then we get, I told you, 95% ethanol, but if we want to have 100% ethanol, then we shall have to use the benzene as a solvent. Though we cannot use water, we can use benzene as a solvent, then you can get the 100% of the ethanol. So this is like this. We can add some kind of chemical to make the alcohol denature. This is how this is in practice in the industry. Now, first step is the preparation of starter, because we have 10 milliliter of sterile oat. Oat is actually, this is the it is a liquefied starchy material, and this is suitable for the fermentation purpose, and this is where yeast is grow, and then we incubate 25 degrees centigrade, then put it 200 milliliter of yeast culture, then we incubate again at 25 degrees centigrade to the 4 liter yeast culture. Then with this yeast culture we use in the inoculum vessels or produce the inoculum, then finally we put it in the fermenter. Now the raw materials addition, that molasses contain 45 to 55% weight by volume, that is sugar, and sugar concentration of the fermentation broth usually varies from 10 to 30% weight by volume, because initially that maybe 15-20 years before, that alcohol concentration of the fermentation broth was 7 to 8%. Nowadays it is due to development some osmotolerant and yeast tolerant, alcohol tolerant yeast cells, it is possible to increase the alcohol concentration up to 15%. So the sugar concentration also increased to a great extent. Now nutrient, although the molasses contain most of the nutrient, in some cases ammonium phosphate and sulfate are added to supply the nitrogen source. This is usually. Now here I want to point out one thing, very interesting thing, that I told you that in yeast fermentation process, usually maintain the acidic pH, that is 4.5 to 5. This is the pH that we maintain. Now diammonium sulfate is used. When you use the diammonium sulfate, make a solution, we get the ammonium hydroxide and H2SO4. So since the H2SO4 is highly acidic, and this is the weak base, so when you make a solution of ammonium sulfate, the pH will be acidic. So you don't have to add some acid to maintain the pH. Automatically the pH will be acidic. So that is why ammonium sulfate, that usually prescribed as a nitrogen source, greatly used for yeast fermentation process. Now that I told you the pH is 4 to 4.5 is used. Oxygen is needed at the initial stage for the growth of the organism, for the preparation of the inoculum. Then anaerobic condition, then the anaerobic condition is established because in the fermentation process of the organism use whatever dissolved oxygen present there for their growth. Then automatically the anaerobic condition that prevail, that and due to the evolution of carbon dioxide. Temperature 20 to 30 degrees centigrade and fermentation time is 50 hours. Now distillation, that if you look at the distillation, that is the fermented liquor is distilled to separate the ethanol, fusel oil and other constituents present in the fermentation broth. I told you fusel oil nothing but higher alcohol like amyl alcohol. Amyl alcohol, butyl alcohol. So different type of alcohol is produced. This is the higher alcohol. This causes the bitterness if we in the beer, but this is very much useful when we use this as alcohol, use as a power alcohol. This increase the Cittern number. So different slopes and fractions contains the alcohols are separated. Fractions containing 60 to 90% alcohol I call the high wine, and those fraction low alcohol we call it low wine. The solid from the slopes are used as the fertilizer and fodder, because after the separation of the alcohol whatever things remain, that is called stillage, that can be used for either used as a fertilizer or fodder that can be used, or this can be used as a raw materials for anaerobic fermentation process for the production of methane and carbon dioxide. Now this is kind of typical block flow diagram. Black strip molasses, what you cane molasses, we take it, we mix it in a mixer with water, with significant amount of water we add here, and then it passes through the fermenter, it is fermented, and from the fermenter the beer still, and from the beer still we have rectifying column. Rectification column we get 60% alcohol. Further we passes through the rectification column, so we get the 95% alcohol. Then we can produce the anhydrous column, or you use the azeotropic distillation process by using benzene as a solvent, we get the absolute alcohol. Now in the beer still, after the distillation of alcohol, whatever the left we call is stillage, you can drum dry and we can use as an animal feed, or this is when it undergoes the destructive distillation process, it produces the activated carbon. Now I was talking about the fusel oil. This alcohol during the distilled product we get some fusel oil. The concentration of fusel oil is about 0.1 to 0.7%. Normal propyl alcohol, amyl alcohol and butyl alcohol, these are the different alcohol present in this fusel oil. Now process flow diagram is like this. We have grain, because we have taken the example, I told you that not only that alcohol produced from cane molasses, but we use the broken rice. The broken rice we can take it, here we have the milling machine, then we can slurry, then liquefaction, and then not only liquefaction, we heat it to gelatinize the starch. After gelatinization we add enzyme here, amylase enzyme for the saccharification, and this saccharified material we have sugar, we put it in the fermenter where we add some yeast and nutrient, and when it will undergo fermentation process, and then after the fermentation we distill this, we pass through the rectification column, we get the alcohol, we take the water out, and the stillage is coming this way, mixing and drying. This is DGGS, the distilled dry grain solid, that also is the use. Either it can be used as a very good fodder. It can be used fodder in the by different industry. They use for the fodder. So by adding some other nutrient, more by fortifying this with other components. So this is the typical process flow diagram of the alcohol fermentation process using the starchy raw materials. Now, denatured alcohol, I already explained that I want to discuss. I don't like to discuss again, but the fusel oil, I want to tell that this is 0.1 to 0.7% of the crude distilled spirit. It is a mixture of amyl and isoamyl alcohol, primarily smaller quantity of isobutyl and normal propyl and trace amount of acid esters and alcohol. This is also used as a lacquer solvent. I told you fusel oil also acts as a octane number enhancer. So when you use alcohol as a powered alcohol, then it is desirable. It will improve the quality of the fuel. But when you use as a for human consumption, then this is not desirable because this gives a bitter taste. Now, alcohol industry, one problem is that distillery, that effluent that is produced here. I want to discuss one very important aspects that I told you that the concentration of alcohol plays important role for the effluent production process. The correlation between the percentage of alcohol present in the fermentation broth and the volume of effluent produced per unit volume of 95% ethanol, it is like this. Now, this clearly indicates that as the alcohol percentage increases, the volume of ethanol production also drastically reduces. Now, in the early days, because we have 15 to 20 years before, in India most of the fermentation process has been carried out in the batch fermentation process, and where we get 7 to 8% alcohol. Now here if you have 7%, so it is approximately equal to 12 to 13 liter alcohol per liter distillery effluent per liter of alcohol. Nowadays this has increases, the ethanol concentration increases to 14 to 15%, and the volume is drastically reduced. So this is the typical advantage of the efficient fermentation process. Efficient means with respect to higher concentration of alcohol production in the fermentation process. So BioSteel is a kind of company. They come with this continuous process to improve the ethanol production. Nowadays some industry in India, they are using this process because continuous process, the alcohol productivity is much higher as compared to batch process. Now in the BioSteel process, the fermenter operate in a steady state. I showed you this is the start tank reactor. In the start tank reactor, it is possible to maintain the steady state, and steady state means the concentration under steady state condition, the concentration remain unaltered, continuous addition of sugar containing substrate and continuous removal of ethanol. I shall explain the process with schematic diagram, and then we have this continuous return of yeast that take place. So one drawback we discuss of the ethanol, that CSTR, is that continuous cell mass the bleeding from the reactor, because we in the continuous start tank reactor always we lose some cell mass. So we have to maintain the cell mass concentration constant, we recycle back some of the cell mass in the reactor to maintain the cell mass concentration constant. The fermenter volume needed for a certain capacity is typically only half what is required for other processes, because volume is drastically reduced and minimum effluent generation. Now here I want to point out also the manpower requirement in this particular process is drastically reduced, about 10% as compared to the batch process. So in that way this process is found very economical for the ethanol fermentation process. Now, schematically this can be explained like this. This is a continuous CSTR process. You can see this is the starter and this is your sugar you are putting inside the system, and continuously it produces carbon dioxide, and then it passes through the centrifuge, and this concentrated it passes it goes to the centrifuge, then concentrated cell you recycle back, some cell you take it out and take it out here, and then we pass it through the distillation process, and after distillation process some of the liquid when you use you take it back. But the reason is that because I told you that cane molasses contain about more than 50% or approximately 50% of sugar, but sugar concentration in the fermentation broth is quite less. So what you have to do is we have to dilute this cane molasses significantly. The significant amount of water is required. Now, if you can recycle this effluent, then what will happen, that effluent contains some unconverted sugar that will get an opportunity to ferment further, and also water consumption in the fermentation broth will be reduced to a great extent. In this way, we make the process, they make the process very economical, and amount of, as I told you, amount of stillage production, amount of effluent production is drastically reduced. This is also 1/10 as compared to the batch process. So the expenditure involved for the wastewater treatment process also significantly reduced. Now, I want to discuss one problem with the distillery industry. This is very interesting problem, that suppose the question is, one distillery industry is producing 100 cubic meter of rectified spirit containing 90% of volume by volume of ethanol. So, in a chemostat from cane molasses containing 50% weight by weight sugar using Saccharomyces cerevisiae. The characteristics of the yeast cell is given here. Okay, this is under anaerobic condition. Aerobic condition, the characteristics of the organism will be different. So, mu max is 0.05 hour inverse, Ks is 2 gram per liter, Yx by S is 0.05, Yp by S is P by S means ethanol, gram of ethanol per gram of substrate consumed is 0.5, S0 value is 300 gram per liter. Find out the volume of the bioreactor and amount of cane molasses required per day. So, I can schematically I can write this process like this. It is like this. So, we shall have to produce that. Here we are targeting basis, because everything is what is the basis? Basis is 100 cubic meter rectified spirit let us assume per day, or the rectified spirit, not per day, rectified spirit. That is the production that we have, and let us assume this is per day is the production. We can elaborate that. I think that we can per day. So, and which contain 90% of volume by volume of ethanol. So, here we put the cane molasses, which contain about 300 gram per liter of sugar. Am I right? So, if we suppose, and then we operate this, we have this equation x0 value here. Here we assume this x0 value here is 0, because we assume this is a sterile feed. Sterile feed we can assume. Then what will happen, that this is rotating like this. Then we can find out under steady state conditions where first we can find out what is the, at what dilution rate we can get the maximum cell mass production, because we observed that rate of product formation is proportional to rate of cell mass growth, because we already pointed out the ethanol fermentation is a growth associated product. So, since it is a growth associated product, so we assume that if there is the maximum of cell mass growth, that will give the maximum amount of product formation. So, we try to find out that at the under what circumstances it produces the maximum amount of cell mass. So, we calculate the Dmax value. The Dmax value is equal to mu max. It is mentioned here. Mu max 1 minus root over Ks by Ks plus S0. Then we have all the values here. So, we can find out the Dmax value is 0.046 our inverse. Now, under steady state condition, we already find out that under the steady state condition and sterile feed, we find D equal to mu. So, this is equal to mu max S Ks plus S, and from that we can easily find out the value of S. S is coming as Ks D mu max minus D. Now, this D we can replace by Dmax and we can find out the value of S. So, S here S is coming about 23 gram per liter. So, here it was 300 gram per liter is coming like this. By substituting we can find out the cell mass concentration. Now, 100 cubic meter spirit, that means 90% volume by volume, that means I can assume it has 90 cubic meter ethanol is to be produced per day, and 90 meter cube of ethanol is equivalent to 90,000 liter of ethanol per day. Now, density of ethanol, pure ethanol, is 780 grams per liter. Now, if it is like this, then we can easily calculate how much ethanol is produced. This is about 70.2 into 10 to the power 3 kg ethanol per day. Now, then we can easily find out the substrate required is how much. This is 140, because the Y/P by S ratio, that is gram ethanol per gram of sugar, is this. So, you can easily calculate that what is the how much sugar is required per day. Then volumetric flow rate we can find out, because this is the substrate required divided by that initial substrate concentration, we can find out what is the flow rate. Now, since this is the CSTR, we can easily find out if the tau CSTR, the space time that required for the continuous start tank reactor is the S0 minus S minus RS. This already we derived in our previous lectures. Then a minus RS I can write. This is how we can write the minus RS, because minus RS is equal to minus ds by dt. The minus ds by dt I can write ds by dx and dx by dt. This is minus, this is equal to y x by s into this is mu into x. This is exactly what it is written here, and then we can calculate the value of minus RS, and once you calculate the minus RS, then we put the value in the tau CSTR. This is the S0 minus S minus RS. We can easily calculate what is the value of tau CSTR. Now, tau CSTR is coming at 21.74 hour, and then this is equal to V by F. V by F is this is equal to the volume by volumetric flow rate. Volumetric flow rate already we have calculated, and in the previous we have calculated the volumetric flow rate is 19.5 meter per hour. So, here we can put these values, we can multiply this with the tau CSTR, we can get the volume of the reactor. The volume of the reactor is coming like this, substrate required is this, and cane molasses content about 50% of sugar. So, you divide by 0.5, it will coming 280.8 into 10 to the power 3 kg per day. So, this much of cane molasses is required for the getting 100 cubic meter of rectified spirit. So we can easily calculate. It's not very difficult. We can calculate that whatever amount of ethanol produced by the industry, we can easily calculate. And since nowadays most of the industry they are going for CSTR process, because which has the higher productivity. So this kind of analysis always will be helpful. Thank you very much.